Hello everyone. We will solve a problem on histogram. This is from January 2018, paper 2. Group data are often represented graphically by histogram. A histogram consists of rectangles and it is a very popular graphing tool. It can summarize discrete or continuous data that are measured on an interval scale, and it is often used to illustrate the major features of the distribution of the data in a convenient form. And when we deal with large quantity of data, suppose in this case, we have 100 observations. So histogram can be a very useful way to represent this group data. So we have an incomplete table that weight of 100 tomatoes are given here. So the last row is incomplete, we can see. So total number of tomato is 100. So 16 plus 28 plus 32 plus 14 is giving us 90. So the last row frequency will be 10. And from the histogram, we can see that the vertical axis is representing the frequency density and the horizontal axis is representing the class interval for the weight. So frequency density is frequency divided by class width and the vertical axis is not labeled. So at first we will label the vertical axis. Frequency density will be equals to frequency divided by class width. So we can see that for the interval 30 to 35, a bar has been drawn, 30 to 35, second row. So here class width is 5 and frequency is 28. So what will be the frequency density for the second row? Frequency density is frequency divided by class width, 28 divided by 5, which will give us 5 whole 3 by 5. Also, we can write 5.6. It means that the height of this bar is 5.6. We can label the vertical axis. This height is 5.6. Then the last row, 10 is the frequency and the class width is 20. So what will be the frequency density for this row? Frequency density is frequency 10 divided by class width 20 equals to half, 0.5. So height of this bar is 0.5. This is half, 2.5 unit is 0.5. So now we will label the vertical axis. 1, 2, 3, 4, 5, 6, and 7. Now our vertical axis is labeled. From the first row, we can see that frequency is 16 and class width is 10. So frequency density will be 16 over 10, 1.6. So class width 20 to 30, height of the bar will be 1.6. 20 to 30, height of the bar will be 1.6. .6 is the height. For the third row, frequency density, we can find out frequency density equals to 32 divided by class width is 5. 32 divided by 5. 6 whole 2 by 5 or 6.4. So class width 35 to 40, height of the bar will be 6.4. Height of the bar will be 6.4 for class interval 35 to 40. Okay, so we have drawn two bars and the fourth row frequency density equals to 14 over 10. The class width is 10. 14 by 10 will give us 1.4. So 40 to 50, the height of the bar will be 1.4. This is 1.4. Sorry, this is 2.4 I am drawing. Our height of the bar will be 1.4. This is our 1.4. So we have completed the histogram. 4 marks for question number 6A. We have completed the table as well as the histogram. Now, question number 6 continued. 6B, calculate an estimate for the mean weight of the 100 tomatoes. So they are asking for an estimation, not the actual mean, because they did not provide the actual weight of 100 tomatoes. I mean, individual weights of 100 tomatoes. So 20 to 30 grams weight, there are 16 tomatoes. So in this case, we will consider the mid value. Mid value. So 20 to 30, mid value is 25. 30 to 35, mid value is 32.5. 35 to 40, mid value is 37.5. 40 to 50, mid value is 45. And 50 to 70, mid value 60. Now to estimate the mean, 25 times 16 plus 32.5 times 28 plus 37.5 times 32 plus 45 times 14 and finally 60 times 10. So this is our estimated total weight of 100 tomatoes. This is not the actual weight, estimated total weight of 100 tomatoes. So it will be divided by 100. So we will divide it by 100. So after calculating, we will get that the mean weight of each tomato will be 37.4 grams. This is the estimated mean, 6B. So this is the end of question number 6. Thank you, everyone.